All right, so these types of problems you should be able to answer pretty quickly, right? This was like those ones from 2-3 that I gave you, just the 5-minute little quiz. And so in looking at this, what you should be able to do is understand, again, my recommendation is first apply the negative power. That's going to move your base into the denominator, and it changes the sign of your power. Okay, and now you can apply the different parts of that power. So again, can you take the cube root of 216 and simplify your base? Yeah, that's the last of the ones that you need to be familiar with. 216 is 6 cubed. So the cube root of 216 is 6. You still have that power of 2. So we apply the cube root first. And then the last step, 6 squared is 36. And so you get your solution. Okay. In the second example, the same idea. Apply the negative first. Okay, so the negative is going to stay out in front of the whole thing. The base of 64 gets moved to the denominator, and you change the sign of your power. Okay, now, again, you're either going to cube it or square root this. Can you take the square root of 64 and simplify it? Yes. So here we have our minus, the 1 out front. We turn this into an 8 cubed. Now, if I gave you a problem like this, 8 cubed is not one that I expect that you are familiar with. Okay? However, if you multiply it out by hand, you could. If you did that, you would get 512 as your answer. And so either of these forms would be acceptable for that second question. I'm going to talk through the first one and then give you a little bit more time for the second one. In case you didn't quite get the first one, you'll see it done once. All right, so when we rationalize this, what we first need to do is look to simplify our radical. Well, there's no perfect cube factors that you can remove from 49, but what do you recognize about 49? Yeah, it's a perfect square, right? So if we think of that as 7 squared, it helps us when we choose to rationalize because now we're not using a base of 49, we're using a base that's smaller, a base of 7. So when we rationalize, we're going to use the same index, cube root, the same base, 7, and then we're going to build this base up to higher powers by looking at comparing the powers of our base 7 to the index. So our index is 3, so we need a total of 3 for our power of 7. We have 2 to begin with, so how many more do we need when we rationalize? Just 1. Okay, so when we simplify across the top, we get 8 times the cube root of 7. And then across the bottom, we get our 3, our factor of 3 stays. And then the cube root of 7 cubed is going to be just the base 7. And so if you simplify that completely, 3 times 7 gives you 21. Okay, so again, the way that you would enter this online, you would spell out cube RT for the radical / 21. So this would be how you'd enter that online. Right, now, a couple things that I want to make sure that you're aware of. One of the other common mistakes that I haven't talked about yet when students look to rationalize is often they think they need to use the entire denominator, meaning that they might need to use this 3 as well. Well, look what happens if you did. Right? If you multiplied by 3 over 3, what are these 3's eventually going to do anyway? They just cancel out anyway, right? So there's no reason to do it. You don't need to use the factors that are outside of radicals when you're rationalizing. They're just going to cancel each other out later on and complicate things as you work through it. All right, so if you haven't done this second problem, I'd like you to give that a try and see if you can simplify that expression, please. All right, let's take a look at this. So here, once again, there's no perfect powers of 5 that are inside our radical, but what do you notice about 9? It can be expressed as 3 squared. So when I rationalize, now instead of using a base 9 to the power of 4, which is too complex, I'm using a base 3. So when I choose to rationalize, my index has to be the same, 5th root. Okay, my base has to be the same, 3's. And I have to build up the base to higher powers based on this index. So my index was 5, so I need a total power of 5 for my base 3's. I have 2 to start with, so how many more 3's do I need? 3. So that's how I choose to rationalize. And now when I simplify this out, I get -8 times the 5th root of Since I know 3 cubed is 27, I can expand that out. And then in the denominator, I have 5 times, again, the 5th root of 3 squared times the 5th root of 3 cubed is going to be the 5th root of 3 to the 5th. Again, it's why we chose to build the powers up that way, so that the index and power are exactly the same, canceling out, leaving just the base 3. So our answer winds up being -8 times the 5th root of 27 all over 15 as our final solution. Once again, if you were entering this online, -8, you'd spell out 5th RT 27/15. Okay, so this is what it means when it asks you to write it in radical form and rational form. The rational form just means write this divided by 15 instead of writing like 15 to the power of -1 or using negative powers for your denominator. All right, questions on that? Single term, rationalizing single term fractions. All right, so the last type of problem that I want you to take a look at and that you'll be responsible for on Monday are double term denominators. Once again, I'm going to go through the first one here and then give you just a few minutes extra to do the second one if you haven't, or if you didn't get the first one quite right. Okay, so in looking at this first one, step 1, you simplify your radicals. Can we simplify root 20? Yeah, so I'm going to go ahead and do that first. I'm going to rewrite this as 4 root 20. What perfect square factor can you remove from 20? You get 4 times 5. The square root of 4 comes out as a 2, root 5 minus 1. So here's our new fraction, 4 over 2 root 5 minus 1. Okay, and now I can rationalize. When I rationalize, I'm going to multiply by the conjugate, same terms, 2 root 5 and 1, opposite sign between them, so a plus. And so when I simplify that, I wind up just multiplying across the top, 4 times 2 root 5 plus 1, and then multiply across the bottom. Now, when I square this first term, either, again, think of it as squaring the 2 and squaring the root 5, or since we already have that form, the simplest form here inside the radical, just square this term, right? What is the square root of 20 squared? Just 20, right? The root and the power cancel. And then minus the next term squared, 1 squared. And so you get your final answer, 4 times 2 root 5 plus 1, all over 19. All right, so again, if you haven't already, or if you didn't quite get that problem, take just a minute or so, see if you can answer the last problem here that we'll go through. All right, in this second problem, you look to simplify your radical first. Nothing to simplify, so we're going to go ahead and rationalize. We multiply by the conjugate, which is same terms, root x and 2, opposite sign between. And when we multiply across the top, we get 4 root x minus 2 all over. And now we just take the pattern. It's the first term squared, root x squared, the root and the power of 2 cancel, leaving x. Always a minus, 2 squared, which is 4. Can I cancel these 4's? No. This is a monomial factor. This is a term of a binomial factor. You can only cancel if they're exactly the same. There's nothing else to simplify here. And so this would be your solution.